Okay, this is the Blocking Dogs lab. And so what we are wanting to do is take a look at different dogs. We have some Akitas here in the top left, Beagles, Collies, and Dalmatians. And what we want to do is handle bone density loss in dogs. Okay, so we're wanting to see, is there a treatment that we can do to help the bone density loss in dogs, and we want to see if there is a treatment that we can do to reduce or help that problem. All right, so we have 3 different treatments that we're going to be experimenting with. One of the treatments is exercise and calcium. One of the treatments is calcium only. And then one of the treatments is the control group, so they would not get any of the treatments at all. Okay, so let's go ahead and take a look at the papers in your lab packet. And so that would be this. It's on page 40 through 42 in your packet. And so what we're going to do is we're going to collect data, and we're going to get these different numbers here. So we're going to collect 8 different numbers, 8 numbers for the exercise and calcium, 8 numbers for the calcium only, and 8 numbers for the control group. And those are going to be the numbers of the bone density loss number that dogs in our sample had. So here's how this experiment works. Each student is given a card, and the cards look like this. And so, for example, in this card it says, you own Pepper. Pepper is your dog, and he is a Beagle. Now, just by virtue of you being a particular breed, you've got a bone density number, okay? And then, by virtue of you being in a particular clinic, this Beagles and paw prints, you have a clinic number. So this is a -3. So actually, this clinic doesn't help the dogs enough to reduce bone loss, so it actually you're still going to have bone loss even if you go to that clinic. This letter D is going to represent the average bone density change for all dogs, okay? And then in class we used this other source of variability, and we did a random computation of another number to take care of all of the other unexplained variables that we haven't got accounted for here, like exercise, food, if the treats or whatever other unexplained variables that the dogs might get and that contributes to bone density loss. Okay, so with that being said, then we're gonna now we're going to take a look at the experiment cards, okay? So what we're going to do is each person then has one of these sets of experiment cards. And so we are going to do 3 experiments. We're going to do a completely randomized experiment, and then we're going to fill in our numbers here. So this number is -105. That's the density. Our dog was a Beagle, and his number was a 9 right there. Okay, and then remember, and then our clinic number was -3. So our clinic number was -3, and the treatment is given to the student by the teacher, and then this other. We computed in our calculator as a random number, and so the number I computed, it can be a positive or negative number, it doesn't matter. The number I computed was -5. So this is simulation number 1, so we're going to do that first. And the teacher hands out, randomly assigns treatment cards to the students or to the dogs. So let's recall that in a completely randomized experiment, we have the situation that is like this. Okay, we have this situation where you have all the dogs, and then you're going to straight up randomly assign, so randomly assign with a simple random sample to the treatment groups. You're going to get the either exercise and calcium, the calcium, or the control. And then you'll measure, okay, you'll measure each dog, and then you will compare the average or the proportion. And so here's what the treatment cards look like. So the students either got this exercise and calcium one, this calcium, or a control. So we're going to say that our dog got this one, exercise and calcium. And so that means that our dog got the number 6 here. And so I'm going to total all of these numbers up, and that's how I'm going to get this value right here. Our treatment was exercise and calcium. So let's add those together and get our number. So this gives us a sum of negative 98. So we're in the exercise group, and our number was negative 98. Now, the entire class, all 24 dogs, will give their numbers. There will be 7 other ones in the exercise group, 8 in the calcium group, and then the ones in the control. And so then here is an example of some data. So after you have taken all these numbers and then you have put them on the appropriate line here, we graphed the numbers on the EX, and then the calcium would go there, and then the control goes there. So after you graphed all those numbers, then you have now completed this completely randomized experiment. So now we're going to do this block by breed experiment. And so let me remind you, and we talked about this in class, we would block by breed because we think breed has an effect on bone density loss. Say these things specifically. Do not just say, I think breed has an effect on the results, or breed has an effect on the outcome, or breed has an effect on the dogs. No, breed has an effect on bone density loss. All right, so now some of these numbers stayed the same. We had the negative 105, we had the 9 for our beagle, our clinic was negative 3. The way we're going to block by breed, and I'll get you the treatment in a minute, and then the other, I also randomly generated another type of random number, and I got a 2 on that one, positive 2. All right, so this is going to be simulation number 2, and then I'll get a treatment here in a minute. But here's how we are going to block by breed. There are 4 breeds in this experiment. The 4 breeds in this experiment are the Akitas. We had the Akitas, the Beagles, the Collies, and the Dalmatians. And so what I do with all of the students in the class is I say, okay, if you have a dog that's an Akita, come up and group yourself right here in this area. If you have a dog that's a Beagle, come up here and group yourself in this area. So I group homogeneous groups by breed. So I've got all the Akitas together, all Beagles, all Collies, and all Dalmatians. Now, after we do that, then so after you do that, so basically you're going to take all the dogs. You're going to take all the dogs. You first control, and you control by blocking. So control, then randomize, and then repeat. So you control by blocking. And so I'm going to block by breed because breed may affect bone density loss, and I'm going to do the Akitas, the Beagles, the Collies, and the Dalmatians. Okay? All right, now after that happens, then the teacher will come around and we'll take these treatments and let me just go up. I'm going to go up to the Akitas. So I'm going to go to the Akitas, and I'm going to randomly assign the 3 treatments. So within the Akitas, I'm going to do random assignment. And let's just, so those would get that. And then amongst the Beagles, I'm going to do that as well. I'm going to randomly assign to exercise, calcium, or control. Random assignment. And that's the group we're in. So the teacher comes up and will randomly assign you. This one, let's say that we got the control. So our little Beagle got the control, and so that's our data. And so we're going to go ahead and get our information. And so that's going to look like this. Let me go ahead and move these out of the way. So our control was -8. And so then whenever I combine those pieces of data together, I get -105. So that's my sum right here. And I had the control. So after I have my piece of data, and see, I am sitting with my other Beagles. We are blocked by breed, so I am sitting with all my Beagle people. And so we're going to be filling out this section right here. Okay? So I sit with my Beagle people and I say, hey, Beagle people, okay, because 2 of them got, one thing and 2 got the other, and so on. So here are some numbers that we got. So I had, let's see, what was I? Control. I was in the control group, and my number here was -105. See, I was control. Well, I asked my people in my group, and another person who had a control was -98. Okay? And then I asked my people in my group who had the calcium treatment, and there were 2 of them, and their numbers were -113 and -101. And then, you know what, I don't actually, let me switch those. Let me change that up a little bit. Sorry, those were the wrong numbers. So let's do this one. This was -96 and -89. And then my Beagle people, my Beagles were, for this treatment, exercise and calcium, they were -87 and -92. Okay, so what we do then is we want to see what is the average amount that this breed contributed to this situation. And I'm going to average that, and I get -95. So just by virtue of us being a Beagle, we on average have this happening. We have this bone density loss just because on average we are a Beagle. So we are controlling breed. So with us controlling breed, and this is really important that you get this, we are going to take away that issue of us being a particular breed. And by taking away, we're going to subtract away this number that happens just because we are a Beagle. So here's how that works. In each cell, so think of this as a matrix. In this top left cell here, I am going to take this top number here, this -87, and subtract away the average that's happening because of the fact that we're a Beagle. So this number gets computed as -87 minus -95. And so that number I get is an 8. So that number goes right there. Okay, and so then we do that for each cell. So each cell, then we do that -92 minus a negative, and that would be a +3, and so on. And so we end up getting the data for those. Let's see. So I'm bad at subtracting, but let's see if I can't do that real quick. 6 and then -3. Okay, so those are those numbers there. Let me go ahead and give you an example of what the rest set of data that my first period had. The Akita group came up with these numbers here, -3. Okay, and then for the Collies, we had these numbers. And finally, for the Dalmatians, we had these numbers. Okay, so let's look at what we will graph. So we will take this information, and so we will then say, okay, here, this exercise and calcium numbers, I'm going to come and graph those on this line right here. Okay, and I'm going to say, okay, you calcium only numbers, I'm going to take this and graph that on this calcium line. And then I got one last thing. Okay, and then of course, here's our control data, which we will then graph on this last line here on the control. Okay, so that is blocking by breed, which is taking out the numbers related to the fact that you are a particular breed. Okay, we have one final thing to do, and we're not going to go all the way through this, but here's what happens. We have this one other experiment, and the other experiment that we have is blocking by clinic. So this is our last experiment. We're going to block by clinic, and so we know that we've got our regular old numbers here are -105. The fact that we're a beagle is a 9. This was a -3. We'll get our treatment here in a minute. And I computed another just other random value, and that was a -1. Okay, so then we group by clinic. We block by clinic because we think the clinic might affect. So here's how that design will look. We're going to take all of our dogs, and we're going to control the fact that you are in a particular clinic. So we will block to control that. And the blocking is, we got paw prints. That's one clinic's name. We got Pooch Palace. That's another one's name. We have Treehouse. That's the third clinic's name. And then we have Barking Lot. That is the last clinic's name. So we're wondering if the fact that you go to a particular clinic has an effect on bone density loss. So we're going to block by clinic because we think that could affect bone density loss. So now, let's see, what was our clinic? Our clinic was paw prints. Okay, cool. So everybody in the class who is a paw prints will group together. We're going to group the paw prints together. And then I will randomly assign to either the exercise and calcium, or control group. So that's what we're going to do now, and then we will get all of those numbers. So here we go. This is how this will look. So here comes our third situation. We're going to block by clinic. We are in paw prints, so we are in this section right here. So my little group that I'm sitting with is going to collect this data right here. All right, so the teacher's coming around and is shaking up in a big bag and is going to randomly assign me a treatment, and the treatment I get is, I get another control. So I get another control card. So, let's see, I do not want those to be connected together. So, well, those got connected together somehow. All right. Let's see if we can get rid of this picture. Okay, we'll try that. All right, that picture's gone. So here we go. Let's finish this out. So I'm going to get my numbers, and the same thing is going to happen. I don't want to go through this all over again, but the same thing's going to happen where you get 6 numbers here. We look at who has the particular treatment. We're calcium, and so we get our number and we put it down here, whatever that ends up being. Okay, you get the average and you subtract the average from that clinic. So I am doing this. I am removing the variability because you go to, I'm removing the numbers, the bone density situation, because you go to a particular clinic. So then after that, we get all these different numbers, and here is an example of numbers that came from first period today. The numbers in paw prints were these: 9, 10, -2, -38, 23, and -1. Pooch Palace are these numbers here. I'll go ahead and I'm putting these numbers up so that you at least have some data if you need it. And then Treehouse. And finally, Barking Lot, 42, 3, -40, 33, -45, and 6. All right, so in summary, we have done 3 different experiments. We have done a completely randomized experiment. Let's see if I can clear off some of all of this stuff going on. We did a completely random experiment. We did a block by breed experiment. And we did a block by clinic, okay? So after doing all of those, we collected all the data, and what the class's assignment was to do homework, was to do the graphing of these lines right here, graphing all the data for all 3 experiments. And then we're going to discuss the patterns that those look like tomorrow during class.